Hi everyone, I'm Ishan from First Updates Now FTC, and you're watching Behind the Bots, where we show you what makes FTC robots work. We're with Team 16397, Relatively Quantum from Ontario, Canada. They've got a really awesome bot here that won them the Innovate Award at their first qualifier, and they also won second place Inspire at their last qualifier. We're here with Arman and Maz, who are going to tell us about their intake, their shooter, and some of their cool stuff with their wobble goal mechanism.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumper segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com, and let's get your team scheduled to be on First Updates Now. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content.
So let's get right into it. Earlier you were showing me a little bit about how your wobble goal mechanism was able to do autonomous and teleop. Can you talk a little bit more about that?
Yeah. So our wobble goal mechanism, there's a gate that opens, so then the wobble goal can just slide right in. And then when the gate closes, we can just lift the wobble goal right up and position it wherever we want. And for the autonomous, we also have this an extended area, as you can see over here. It's wider, so that even if we miss the wobble goal, we can still get it in the wider area, so we can still drag it around to wherever we want to move it. Great.
And so with that, you use the wider area for the autonomous. How does your autonomous work? Are you able to score both wobble goals?
Yeah.
So, we use the ring detection by using a camera, and then with that wider wobble goal, with that wider area to grab the wobble goals. Once we go deposit the first one, we come back and get the second one, and then we just instead we don't move the arm, we just close it, and then we drag the wobble goal to the correct square.
Great. And can you show me where that camera is and what camera you're using for that ring detection?
So the camera's right over here. It's a Logitech C270, and yeah, it's mounted over here, so it's in the perfect angle to see the starter stack rings, so we don't really need to move closer towards them. We're already able to see it. There's a short demo if you want. You can see that it changes colors of the ring. So depending on how many rings there are, it changes colors. So we can see kind of depending on how many rings the robot knows, how many there are over there. So you just give it a second. Hang on a second.
Awesome, really cool demo right there. So, are you using OpenCV? What software are you using for that ring detection?
So we're actually using it's kind of a mixture of a built-in software that came from First, which is TensorFlow based, and Vuforia. But then we're also, instead of using their built-in detection of quad rings or single rings, we're actually taking the height and width of that detection box, and we're calculating the ratio compared to a threshold. And then depending on that, we're determining whether it's 1 or 4 rings.
Awesome. Really cool stuff. So let's go ahead and take a little bit more look of your mechanical stuff. You were showing me your intake. Can you explain that a little bit more and how it works?
Yeah, for sure.
Yeah, sure. So our intake, it is a chain mechanism with these flaps on it, and these flaps can just hook onto a ring like this, as you can see. 1 second. So these flaps just hook onto the ring and load it into this gravity-fed magazine over here, which is now ready for the shooter to launch into the goal.
Awesome. And so once the shooter shoots it, can you talk a little bit more about your shooter?
Yeah, sure. So our shooter is our shooter wheel is attached to a Rev 1-to-1 ultraplanetary motor, which can spin to up to 6,000 RPM. And so right here we have a servo, which is kind of like this one. So it just flicks the ring into the wheel, and the wheel is spinning. So when the ring gets flicked, it just flies right into the goal.
Cool. And what wheel are you using there on that shooter? It looks like an AndyMark Stealth wheel. Could you talk a little bit more about that decision?
Yeah, for sure. So it is an AndyMark Stealth wheel 4-inch. The reason we went with that is we didn't want to use compliant wheels because we thought it would introduce too much variability into it. And we knew they kind of expanded when they were spun up. So we kind of wanted to set with something a little bit more rigid, which is why we used compliant stealth wheel instead of a compliant wheel.
Yeah, and you have like a piece of metal on the wheel. Can you talk a little bit more what that metal is used for?
For sure. So this is our flywheel weight. And we just kind of have it there because it helps to keep the inertia of the shooter wheel. So once a ring is shot out, we don't need to wait as long for the next ring to get shot out. And that was custom CNC'd with our sponsor Sheridan College.
Awesome. Is there anything else you want to share about your robot? You got a lot of cool stuff here. Oh, actually, I did want to ask you about the LEDs. So what are the LEDs used for? Do you control them during the match? Do you use them for anything else cool?
Yeah, so there's actually a programming interaction with those LEDs. So one of the things we kind of already looked at was the number of rings, but that's more of a gimmicky. Something more useful, it's more of a feature, is after 45 seconds when endgame is about to start, it turns yellow to let the driver know to go start picking up the wobble goal, and then it turns green once endgame starts, so they know they can start going over the line.
Awesome. Anything else you want to share with your robot?
So we have an H drive with a motor attached to every single wheel. And we also have a wheel in the center, which is perpendicular to the rest of the wheels, so that we can strafe laterally. This can be really helpful when we're trying to line up to shoot our rings into the goals.
And why did you pick an H drive over a Mecanum drive?
So originally we did go for a Mecanum drive, but since the weight on our robot, it wasn't evenly distributed. The Mecanum drive, the strafing did not work properly, so we just changed it to an H drive with a perpendicular wheel in the center so that it could strafe better and help us line up.
Awesome. That's going to wrap up this Behind the Bot. Thank you all for interviewing with me, and best of luck in future competitions.
Thank you.
Thanks for watching. If you want more fun content, be sure to subscribe and ring the bell to be notified about our latest videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content.